The next thing that we'll do is we're going to actually find an inverse relation or find an equation for an inverse of a relation or function. Now with the inverse of a function, what happens is we change the input and the output values. We interchange them. So if you think of a function in terms of the function machine, what normally is the input and then gives us output is going to go backwards. So our function machine goes in reverse order. The output goes in and the input comes out, which means the output becomes the input and the input becomes the output, which is a bit confusing, but to do this is actually a pretty simple process. My first equation is y equals 3x minus 1. To find the inverse of this equation, and again, you know what I'm going to do? I'm going to write this in here. So y equals 3x minus 1. So what happens is x values go in, and then they get multiplied by 3, and then you subtract 1, and out comes the output, which we typically label as y. Now for the inverse, we're going to switch x and y, and then we're going to solve for y, because I want to do those steps in reverse. So switch x and y. I switch the input and the output. And then I solve for y because I like to have y be the answer. I like to just use x for input no matter if I'm using the original or the inverse. So we solve for y, which means get y by itself. Add 1. X plus 1 is equal to 3 times y. And then to get y by itself, I divide by 3. Both sides, both parts of that side. So when I'm all done, I'll rearrange it right. Y is equal to x plus 1 divided by 3. If you wanted to divide each of these by 3 separately, you could do that. I'll just leave it for now as one fraction expression. Here's my inverse. Now I want you to think about this. What happened in the original? When I plug a value in for x, I multiply by 3 and then subtract 1, and I get my output. So to go the other direction, we're going to use inverse operations in reverse order. If I had to go backwards, the first thing I would have to do to my input would be, instead of subtracting 1, I'd have to add 1. Well, that's what I do here. I plug something in and I add 1. And then instead of multiplying by 3, I do the inverse of that, which is to divide by 3. So there's 2 steps here in the original. Multiply by 3, subtract 1. So in the inverse, we add 1, then divide by 3. The inverse operations in reverse order. The same process applies even if I don't see a y here. So if I use function notation, the f of x is equal to negative 2x minus 5. The process stays the same. If you want to imagine that this is a y, go ahead and do it. We switch x and y. So x is equal to negative 2y minus 5. And then we solve for y. Add 5 to both sides. X plus 5 is equal to negative 2y. And then the last step would be to divide by that negative 2 to get y by itself. So we got x plus 5 divided by negative 2. Now instead of writing y in the final answer, because this was f of x, I'm going to do something like this. I'm going to write f with a little negative 1 exponent of x. This means f inverse of x, or the inverse of f of x. And it's equal to x plus 5 divided by negative 2. And again, you could divide each of these separately by negative 2, but for our purposes at the moment, I'm going to leave it as is. Because then I can imagine the steps and know that I did this correctly. Because in the original, I multiply by negative 2, then subtract 5. So in the inverse, I need to add 5 and then divide by negative 2. So inverse operations in reverse order. A couple of inverse functions found by switching x and y and solving for y.